All right, greetings, Saintsmen. We're going to get going here on lesson 6.2, which is on bisectors of triangles. And one thing that's going to come up here is with concurrency with regard to triangles. So let's actually talk about what concurrency is. Concurrency is the following. It's when you have three or more lines intersecting. So we've dealt with this in the past where we have intersecting lines or we have just two lines intersecting, for example, like this, okay? Now, if they have a third line intersecting or more, but a third line intersecting through this point of intersection right here, right? This is concurrency. And then specifically, this point where all three intersect is what's called the point of concurrency. Now you guys can see if where I have this and I have three different lines, I'm going to create this because, and I'm interested in this because of applying this to triangles, where I'm going to have three different ways. I have three different angles, three different sides, from which I can construct a point of concurrency. I think the thing that's interesting to consider is what is the middle of a triangle? It's a thought experiment that we're going to explore a little bit more in class, in person. But what is the middle of a triangle? So here's one of these ideas for us to explore, the circumcenter. It's the point of concurrency of perpendicular bisectors. So this is how we're going to construct this. We're going to have a triangle. We could actually do this with, with a compass. And, I'm going to find my perpendicular bisector. So first of all, I'm going to bisect each of these sides, which I could do with my compass. Okay. And then when I do that, I'm going to draw a line perpendicular to each side, right? So it's going to go through here, through this bottom side, right? Doesn't go through a vertex, just goes somewhere randomly through the opposite side, through here. And for all triangles, what winds up happening when I draw these perpendicular bisectors is they will absolutely meet all of these guys through that same point of concurrency, okay? So this guy right here is the circumcenter, and that's the perpendicular bisector's point of concurrency. So this circumcenter is this point right here, okay? Um, what's interesting about the circumcenter is it's you guys get this from with circumference. It's the reason why we do this, right? Is that if from that point I should be equidistant to each of those points on the triangle for all the vertices of the triangle. Okay, so something for us to file away that we'll talk about a little bit later in the course. So let's just jump right into one of these circumcenter problems, which is maybe a little bit challenging. So we are going to find the circumcenter, the coordinates of the circumcenter. And this is something that we're going to have to study in class, that you're going to want to go over this example a couple times because you're going to get thrown right in class having to be able to do these problems. Okay, so for triangle DEF, here are my coordinates. D is going to be 6, 4. E is going to be -2, 4. And F is going to be -2, -2. Now this is going to be pretty much right off of what we did in class. And the thing about this is that if I have, and this is, logically speaking, if I have these points of concurrency, right? I have three lines intersecting at the same point. Now, if the circumcenter is a point of concurrency, it means that if two of the lines intersect, then the third one has to anyway. So what I really have to do is just choose two of the sides. The third one will meet up there anyway. And if I can find that intersecting point between the line constructed off of two of the sides, then I'm good to go. So this is what I mean. Let's just choose two sides. Let's choose side DE and side DF. This is two of the sides from um, of the triangle. Third. So third law of concurrency. So we don't even need to calculate it. Okay, we could do EF, but it doesn't matter. It's going to go to the same point of concurrency anyway. Now, this is for the circumcenter, which means that we want perpendicular bisectors. And we need equations for those perpendicular bisectors. Okay, so this is what we did yesterday for class, and what we did today in class. So it's what we did for notes, and then now employed. So the first thing is we need to find the midpoint of DE and the midpoint of DF. Okay, midpoint of DE is going to be 6 plus negative 2 over 2, comma, 4 plus 4 over 2. Which 6 plus negative 2 is 4, divided by 2 is 2. And then 4 plus 4 is 8, divided by 2 is 4. Okay? So then I have the midpoint of DF I got to do simultaneously. So again, I'm going to have D and F. It's going to be 6 plus negative 2 over 2, comma 4 plus negative 2 over 2. So this first one is going to be 6 plus negative 2, which is 4 divided by 2 is 2. And 4 plus negative 2 is 2 divided by 2 is 1. Okay, so there's your midpoint. Now, I need a slope because I need that perpendicular slope. So I'm going to go ahead and find the slope of DE, which is going to be the difference of the y's, right? 4 minus 4 over negative 2 minus 6, which is going to give me 0 over negative 8, which is going to be a slope of 0. The perpendicular slope, all right? Now think about 0 as a flat line that's horizontal, so perpendicular is undefined. Okay, remember this is a vertical line. All right, and then let's find the slope of DF. Well, I'm going to take the difference of my x's. Okay, sorry, difference of my y's. So I have 4 minus minus 2 over 6 minus minus 2. Okay, which is going to give me 6 over 8, or 3 over 4. So my perpendicular slope is going to be the negative reciprocal, so negative 4/3. All right. So now I need to create two equations here. Okay. So the first one, I need my equation. Now, since this guy is undefined, it means I need to just go back here and take this x value right here. So my equation is going to be x equals 2. All right, so that, right, and in my coordinate plane, it's going to be this, right, over here, and I want what's perpendicular to, 1, 2, 1, 2, 2, 3, 4. Oops, I don't know what this is for. Let's go ahead and get rid of that. Okay, 1, 2, 3, 4, 1, 2, right, and this is the line that's going to go through it. So that's my vertical line. The equation of that, of course, is just x is equal to 2. So boom, I've got that. And then now I need to create my equation over here, which we did in class. So y, right, here's my coordinate, 2, 1. Here's my slope, negative 4, 3. So y minus 1 is equal to negative 4/3. I'm using point slope form. I could do slope intercept, but I'm just choosing point slope. So x minus 2. And then I'm going to distribute here. Y minus 1 is equal to negative 4/3 x plus 8 over 3 plus 1 plus 1. So y is going to be equal to negative 4/3 x, and then plus 1, it's 3 over 3, and that's going to be 11/3, right? So that's my y. I'm going to take this guy, okay, and I'm going to plug right into here. So to figure out what the coordinate of my circumcenter is, well, the first one I have, I'm good to go, okay? The first x is going to be 2. I've already got it. I don't have to solve for anything. Now I just need a y value for my circumcenter. So I plug in 2 for negative 4/3. So y is equal to negative 4 over 3 times 2 plus 11 over 3, which is going to be negative 8 over 3 plus 11 over 3. Negative 8 over 3 plus 11 over 3 is 3 over 3. Oh, which is equal to 1. All right, so that's my y value. Plug that guy in here. And here I have it, my circumcenter, which is 2 comma 1. Last thing that we're going to learn about today is when we have concurrency with the other bisector we dealt with in the previous lesson, which was the angle bisector. So he has a point of concurrency that's called the incenter. Okay. And what the incenter does, it's the point of concurrency for the angle bisector, and it creates an equidistant relationship to each side. Okay, so this is what I mean. If I draw this guy out here, I'm going to draw a triangle here, right? And if I draw an angle bisector, so I'm going to bisect this angle, right? This is congruent. This is congruent. And bisect this angle, okay? This guy's congruent to this guy. And then same thing, bisect this. Oops, gotta do a better job bisecting. Bisecting this angle, right? So this angle and this angle are congruent. And there I have my incenter. And it says it's equidistant to each side. So it's this perpendicular relationship, the shortest distance right here, okay? This guy to the side, and then to this guy to this side. All right? This is congruent to this, is congruent to this. That shortest distance, okay? Whereas the circumcenter was equidistant to each of these vertices of the triangle, okay? And there you guys have it. So that's the lesson. You're going to want to practice the circumcenter problem a little bit so you're ready to go join class because you're going to have a few of these. Good luck.